Alright, so in today's lesson we are going to be looking at linear patterns. So we're going to see how a set of numbers increases or decreases at a set rate. So in this case, looking at this example, we have 2, 4, 6, 8, 10, and it is increasing by 2 each time. Okay, so let's look at some patterns. So if we look at the following pattern, 4, 7, 10, and so on, could you tell me what number comes next? Alright, so if you're good at mental math, you can probably see that in this case we're adding 3 each time. So if you were to say that if 13 was the next number, you'd be right. But let's add some more difficulty. What if I asked, what is the 100th number in this pattern? You probably could still get it, but in this case it's going to be a little bit harder, because if we were to do the brute force method and go 4, 7, 10, 13, 16, 19, 22, 25, 28, oh, I'm running out of breath. If you were to keep doing this, you would eventually get there, but it would take you a long time. And I only wrote down 9 numbers. We still have another 91 to go. So there's got to be an easier way to do this. And there is, and that's what we are going to look into. So if I look at this pattern of 4, 7, 10, 13, and so on, to find the 100th number of this pattern, what we need to do is create a general equation to do so. So, step 1. What we need to do is first find what's called the common difference in this pattern. So what this is the number we add or subtract to get the next number in the sequence. So if I look at 4, what am I adding to 4 to get 7? Which we said 4 is 3. And then if I take 7 plus 3, it gives me 10. So our common difference, or another way to look at it, is if you take your second number and subtract your first number, if the pattern isn't as obvious, we get a common difference of 3. Alright, step 2. What number do we have to add or subtract to our common difference to get our first number? Now, this might seem a little confusing at first, but this is going to be important a little bit later on. Okay, so if we start at 4, and if I have my common difference of 3, what am I adding or subtracting to this to get 4? So if I take 3, add 1, this gives me 4. So this number here is my constant. And when we're creating our generic linear equation for this example, this constant is a very important piece that we're going to need later. Alright, so let's look at our first number. So to get our first number, what you do is you take your common difference, times it by 1, since we're dealing with the first number in our pattern. We add our constant, and if we did everything right, this should give us an answer of 4. So 3 times 1 is 3, plus 1 gives us 4, so that is correct. Now, does this hold true for our next number in our sequence, or our pattern? So for our second number, if we take our common difference, which is 3, since we're dealing with our second number, times it by 2, take our constant, which hasn't changed, so add 1, so 3 times 2 gives us 6, plus 1 gives us 7. So this holds true. And as we can see, this also holds true for our third number, so we know that this is a true statement for this linear pattern. But what we were asked is, what is the 100th number in this pattern? So like before, we wouldn't want to keep doing this 100 times to figure it out. What we can do is use our linear equation to do so. So we can take our common difference of 3. Now since we're dealing with our 100th number, take this and times it by 100, and then take our constant, add it on. So 3 times 100 is 300, plus 1 gives us 301. So 301 would be the 100th number in this linear pattern. So like we said before with the brute force method, You would eventually get there, but if you have to count 100 different numbers, the odds of making a mistake greatly increase. So the odds of making a mistake are quite high. So it's better off to do something that's more sure, like creating a general equation like this. So to have a more generic equation to find any term in this linear pattern, we're going to say that t, our term, equals 3, our common difference, times n, which is the number of the term, plus our constant. So using this general equation, I can find any term or any number of the term in our sequence. Pretty cool, huh? Alright, next example. So we want to determine the perimeter of the 10th set of blocks in the following pattern. So in our first set, we have just a regular square. In our second set, we have 2 squares side by side with one another. And in our third set, we have 3 squares side by side with one another. Now, what I want to know is what is the perimeter of the 10th set if I was to continue these iterations 10 times. So let's look at our first one. So in our first one, we have a perimeter of 4 because we have 4 sides on our square. In our second drawing, we have 1, 2, 3, 4, 5, 6. So that's a perimeter of 6. In our third drawing, we have 1, 2, 3, 4, 5, 6, 7, 8. So in our third drawing, we have a perimeter of 8. Now, so for our pattern, we have 4, 6, 8, and so on. And we want to continue this till we get our 10th drawing. So first, like before, we need to find our common difference. So what are we adding and subtracting to get our next number, in this case, our next perimeter in our drawings? So, at least in this case, it's pretty easy to tell. We're going up by 2 each time. We got 4, 6, 8. But if you're unsure, take the perimeter of the second one, subtract the perimeter of the first one. So our common difference by doing this will be 2. Now, what is our constant? So, to get our constant, we need to take our first number, or in this case the perimeter of the first one, and subtract it by the common difference of our example. So if we take 4 minus 2, gives us an answer of 2. Now, this might seem a little abstract, but since we have a nice visual, we can look at this another way. If I have my first drawing, and I have my second drawing, what is the consistent piece that stays from the first one to the second one in respect to our perimeter? So if I look at the first one, we have a perimeter of 4. And if I look at the second one, we have a perimeter of 6. But the perimeter of the top and bottom of our rectangle has increased, but the length of our sides has remained the same. So our side lengths are what are constant. So since there's 2 sides in both diagrams that have remained constant, that is how we can look at finding our constant. Alright, so get this example, we're going to let P be our perimeter and N be the number of squares or the length of the rectangle in our given diagram. So, to find our general equation, we're going to say that our perimeter with respect to N is 2, so our common difference, times it by the number of squares in our diagram, so N, plus our constant of 2. So therefore, if we want to know what the perimeter of the 10th set of blocks is, what we can do is use this general equation and plug in N equals 10. So P at 10 equals 2 times 10 plus 2, so we get 2 times 10 is 20, plus 2 gives us 22. So in our 10th diagram, our perimeter is going to be 22. Alright, our next example. So let's say instead of having drawings, we're given a table. So a table of values relating t to n. So given these, we have n goes 0, 1, 2, 3, 4, t goes 7, 4, 1, -2, and -5. What we can see is that t is going down by 3 each time. So since that is decreasing by a consistent rate, our common difference is going to be -3. And we just know that by looking at this table, n goes up by 1 and t goes down by 3 for each value. So therefore, t, when we look at our general equation, equals our common difference of -3 times n. But we haven't figured out our constant yet, so we're going to say b is our constant. So t is our term, 3 is the number of the term, and b is our constant. Now, how can we find this constant? With a more generic way, looking at this case, since we have a table of values. So to find our constant b, what we can do is we can plug in known values for t and n, and then use a little bit of algebra and then solve for b. Now, looking at our table, I could pick any set of numbers, but what you want to do is you want to pick a set of numbers that's going to make your algebra a little easier. So for me, having numbers like zeros and ones are usually the ones you want to pick. So we're going to pick our first set of numbers, n equals 0 and t equals 7. So for this, we can plug it in. So when t is 7, that equals -3 times 0 plus our constant b. Okay, so looking at this, what happens when you have anything in times by 0? It just goes away. So this is what makes it really nice, comparing it to any other set of numbers, where when I use 0, it just makes pieces go away. So in this case, b equals 7. So that is our constant in our equation. So we can substitute this back in and create a general equation of t equals -3 times n plus 7. So using this, I could find any term in our linear pattern. Okay, now we're going to tackle some word problems. Alright, so in this example, Sam is tracking the progress of her plant's growth. Today the plant is 5 centimeters tall, and we know that the plant grows 1.5 centimeters per day. Alright, given this, we want to write a linear equation that represents the height of the plant after d days. Alright, so we know that the plant starts, or when she's given the plant, it is 5 centimeters tall, so we're going to think of that as our constant. That number doesn't change. Now, from this, we know we're going to throw in some variables, so h is going to be our height, and d represents our days. Alright, so we're going to create our formula here. So h, our height, since our plant grows 1.5 centimeters per day, that is our common difference. And this increases by the amount of days we have, so we're going to times it by d. And we know the plant starts at 5 centimeters tall, so that is our constant, and we're going to add that on as our constant, so that's our initial height. So this is our general equation for this example of Sam's plant. Now, given this, what we want to know is what will the height of the tree be after 20 days? Could just sit there for 20 days and wait and see what happens, but using some mathematical modeling And if you're given certain parameters and if you know and can predict what's going to happen, you can make an educated guess as to what the result is going to be. And that's one of the wonders of math, being able to predict the future. So, given we want to find our height after 20 days, we can take 1.5 and times it by 20, because that's what d is. D is our days. We're going to add our initial height of 5. So if I take 1.5 times it by 20, that gives me 30. So 30 plus 5 gives us a height of 35 centimeters. So we just calculated that after 20 days, her plant is going to grow to 35 centimeters tall. So math can be quite powerful in terms of predicting outcomes if you know certain parameters. All right.